Okay, so in our second lesson looking at volume, we're going to continue on to look at how we find the volume of a different number of prisms. So just a brief recap, the volume, as you'll recall, is the space inside a three-dimensional shape. That's what the definition is. If you haven't already, it's important to make sure that you've watched the first video on volume, because we looked at how we find the volume of both cubes and cuboids, and we'll do a quick recap on that with an example. We are going to look at in general how we find the volume of any prism. Okay, there's a general rule for this, and that is basically how we find the volume of any prism is we find the cross-sectional area and we multiply it by the length. So whatever that cross-sectional area is, in this case, just a rough example, some form of quadrilateral, find out the area of what that is and then multiply it by the length. So it's important that you are familiar with how you find the area of your different two-dimensional shapes, such as rectangles, squares, triangles, circles, trapeziums, and so on and so forth. Okay, so the volume of any prism is simply given by the cross-sectional area, the cross-section being the end face here, times the length of the entire prism itself. So CSA, cross-sectional area for short, times length. Okay, so again, we've already covered cubes and cuboids, but just to touch on it, because it wasn't explained in this way, we learned that the volume of a cube or cuboid was simply found by multiplying the length, breadth, and the height of a shape. And really that's what you're doing. You're finding the cross-sectional area by multiplying the length and the breadth, these two dimensions here. So we know that the area of a rectangle is found by multiplying the base times height. So you're actually already doing that. So cross-sectional area is base times height, which in this case is 4 times 3. Okay, and then we would simply multiply that by the length here, which is 7. Okay, so the cross-sectional area, 4 times 3 is 12. So the area of this rectangular face in the end of this cuboid would be 12 centimeters squared. Multiply that by 7. 12 sevens, 84 centimeters cubed for the overall volume of this cuboid. Okay. Moving on, we'll look at triangular prisms. And again, we're going to apply the same formula, cross-sectional area times length. So a triangular prism is this type of shape here. If you think of a tent or the likes of a Toblerone wrapper, that's what a triangular prism will look like. The cross-sectional area, the face at the end, is a triangle. So if you're unsure, you can't remember, the area of a triangle is simply the base times the height divided by 2. Okay, so base times height, the base is 6 centimeters here, and we have two heights here. And always remember, when we were finding the area of any shape, we always use the perpendicular height. We have two heights here. We have a slanted height for this side here, and we have the perpendicular height, which is indicated by this symbol indicating that this is a right angle, so therefore it is perpendicular to the base. So we're using this 6 here, and we do not need this 5 centimeters. So base times height divided by 2, we're doing 6 times 6 divided by 2. 6 6 are 36 divided by 2, which is 18. And the whole time we're remembering that we have to multiply by the length of the prism, which is 8. So 18 times 8. I'll just work that out here on the calculator. 18 times 8, which is 144. And remember, my units, because this is in centimeters, centimeters cubed for the volume. Okay, so the cross-sectional area of a triangular prism is base times height, perpendicular height, divided by 2 times the length. Okay. We'll also take a minute to look at cylinders. So another type of prism, a cylinder, if you think of any form of tinned food, that is generally a cylindrical shape. The cross-section of a cylinder is a circle. So if you're unsure or can't remember how we work out the area of a circle, it is very simply pi times the radius squared. And remember, pi is 3.14. The radius is the distance from the center of the circle to the outside of the circumference. So in this case, it will be 4 squared times the length. The length again being 7 centimeters. So we're doing 3.14 times 4 squared. So 3.14 times 4 squared, which is 16. 50.24, and then we multiply that by the length of the prism again, which in this case is 7. So multiply 50.24 by 7, and we get 351.68 to 2 decimal places. 351.68 centimeters cubed again. So again, it's very important when tackling these sorts of questions to recap on the area of your different two-dimensional shapes. Watch the last video on volume and plenty of practice, and I'll post some questions at the end for you to try. And anything you're unsure about, just ask. I will do another video on volume where we will look at prisms where we have shapes such as a trapezium or a compound shape as the cross section at the end.